future Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, inspired and refreshed. Now if my videos are important to your studies, I hope so, then don't forget to subscribe. By the method of least work, determine all support reactions. EI is constant. So in our experience before, we'll just consider bending effects because the other effects such as axial and shear based on the results in the preceding example were negligible. So let's just consider bending effects. This frame is indeterminate to the third degree. Uh, there are three redundant forces to be considered at A, another three at D. So that's why this is indeterminate to the third degree. And we will select redundant forces at A, the reactions at A as the redundant forces, namely AH. Let's assume all these directions AH, AEV, AH, A vertical, and moment at A. And for the sectioning, let's follow the figure shown. So X, then X here, then X, then X. So there are four segments to be considered. First, partial derivative of u with respect to AH equals 0. So let's set up the moment equation in this section here, considering forces below it, in this section below and to the left, in this section below and to the left, and in this section to forces to the left and above. So it is equal to integral from 0 to 4 of EH times X plus MA. And the derivative is x dx over EI, which is 1. So there's no need to divide it by EI. For the next section, it is EH times 4 plus AV times X plus MA. So plus integral 0 to 6 of EH times 4 plus AV times X plus MA, derivative for dx. For the next section, AH times 4 plus AV times quantity 6 plus X plus MA and minus 45X 0 to 3. H times 4 plus AV times quantity 6 plus X plus MA minus 45X then times 4 dx, the derivative of this moment equation. Finally, in this section here, plus integral 0 to 4 quantity AH times 4 minus X plus AV times 9 plus MA minus 45 times 3 derivative 4 minus X dx. So integrating for AH then for MA, we have for the first integral 64 AH over 3 plus 8 MA. For the second integral, we have 96 AH plus 72 AV plus 24 MA. For the third, we have 48 AH plus 90 AV plus 12 MA minus 810. Then for the fourth, 64 over 3 AH plus 72 AV plus 8 MA minus 1080. So combining like terms then equate to 0, we can set up the first equation, 560 over 3 AH plus 234 AV plus 52 MA equals 1890. So call that equation 1. For the second integral, partial of u with respect to the next redundant is AV equals 0. So since there's no AV here, the derivative here is 0. So we copy the moment equation, we just replace this part, which is 0 dx, copy, then this is x dx, this time, 0 to 6. So copy the moment equation, then replace this by x dx. 0 to 4, copy integral 0 to 3 of AH times 4 or 4AH plus AV quantity 6 plus x plus MA minus 45x. Replace this by 6 plus x dx. The derivative of this moment equation with respect to AV. Then copy the moment equation plus integral 0 to 4. Copy. Then replace this part by 9 dx. So evaluating, so the first integral is 0. Here it's for AH, AV, and MA. We have 72AH plus 72AV plus 18MA. Here for AH, AV, MA, and the constant, we have 90AH plus 171 AV plus 22.5 MA minus 1620. So for newcomers, if you want to evaluate this integral one by one and verify these answers, you have to pause the video and check if these values are really correct. Then finally for here, pause the video, evaluate integral of 4 minus x times 9 dx 0 to 4, that's the coefficient of AH. Then for AV, 9 times 9 times 4, that's the coefficient of AV. For MA, 9 times MA times 4, so 36 MA, and then for the constant, you'll get 72 AH plus 324 AV plus 36 MA minus 4, 860. Combining like terms equate to 0, so we can set up the second equation. 234 AH plus 567 AV plus 76.5 MA equals 6480. Call that equation 2. So take note that 234 is the coefficient of AV in the first equation. It is now the coefficient of AH in the second equation. Then finally, we copy the moment equation, then replace the derivative with respect to MA this time. So partial of u with respect to MA equals 0 equals integral 0 to 4. So you copy this, then replace x dx by just dx or 1 dx. So plus integral of, copy, this is replaced by dx only. So times dx. Then plus this one, copy. Then replace this by just dx, the partial derivative of the moment equation with respect to MA. Then for the last integral, integral 0 to 4, so we copy, then replace this by just dx. So the value of the first integral here is 8AH plus 4MA. In this integral, 24AH plus 18AV plus 6MA. In this integral, 12AH plus 22.5AV plus 3MA minus 202.5. In this last integral, 8AH plus 36AV plus 4MA minus 540. So combining like terms equate to 0. Transpose the constant to the right. We set up the third equation. So 52AH, so take note, 52 is the coefficient of MA in equation 1. 234 is the coefficient of AH. So that's a technique if you want to verify your answers. Take note of this experience just to check the equation, especially for the coefficients. So solving these three equations simultaneously, we'll get AH equals negative 13.827 kilonewtons, A vertical 14.091 kilonewtons, and MA equals 22.5 kilonewton meter. So that means only AH is wrongly assigned. It should be rightward. So to finalize the answers, AH is 13.827 to the right, AV is 14.091 kilonewtons upward, and MA is without the direction or sense, it should be negative because it is clockwise. Remember, moment is positive counterclockwise. So we just put this direction, it is clockwise. And from there we can solve dH. So dH is to the left by equation 13.827 leftward. AV is 45 minus 14.091. So that would be dV 30.909 kilonewtons upward. Then summation moment about D equals 0. So MD plus MA, which is 22.5, then plus AV, which is 14.091 times 9, then equals 45 times 3. So MD is negative 14.319 kilonewton meter. So therefore it is counterclockwise, or it is positive. Now the other way of expressing the answers without the direction or the sense, MA is negative 22.5 kilonewton meter, while MD is positive 14.319 kilonewton meter because it is counterclockwise. So that's it for this problem.